So, my name is Sam or Samantha Reese, and today I'm going to do a bit of a presentation on some North Carolina freshwater. I want to do kind of a review on ion composition and some of the threatening pollutants for each of the Piedmont, coastal, and mountainous regions. And I plan to wrap up this talk with some of the certain pollutants that affect all of these regions but are more specific to North Carolina in general. So anybody out there listening, I hope that you guys get something from this presentation. If you guys are in high school or college or anything and just are looking for like a baseline review of everything, I hope this works out for you. But thank you very much for clicking on the link, and I will begin now. So if you guys are watching this presentation, you probably know that freshwater is kind of it's a limited resource more than we typically think about it, especially here in the States. But it is crucial for human life, kind of obvious, but I like to begin that with that. And 1 in 4 people globally don't necessarily have access to clean water, especially like we do. So we can kind of see in the graph here, most of this pollution is not centralized in the United States, but it is a problem here, but it's a problem elsewhere in the world, and we are one of the people that can do stuff to help this and do research to find ways to try to fix this in a way. So to kind of broaden even more like the impact of unclean water supplies, about 1.2 million deaths per year are due to contaminated water sources. So for North Carolina specifically, it's a very regionally diverse area. Here in the blue, we have some of the Blue Ridge Mountains. That's where I'm home to personally, for anybody out here watching. And I really love it. It's beautiful, of course. If you've ever been in the mountains, if you haven't, I definitely recommend you come visit. In the purple, we see some Piedmont regions where the Research Triangle is, a lot of our industrialization. And if you look into the yellow and in the blue, the darker blue, that's kind of just showing the coast and the waterways in general. But that's our coastal region. And a lot of people travel here and travel to our coast for vacations and family events and stuff like that. It's very beautiful, very, very broad stretch of land. But I'll continue this a little bit more later in the discussion, but it is still probably one of the more affected lands of North Carolina or regions. So North Carolina freshwater is actually some of the purest freshwater that can be found, and most of this is found in the mountain springs. So this is actually kind of groundwater that's been sitting underneath the earth for a very long time that is able to approach or reach us through these springs that come straight out of the mountain. But so from this, there's been a lot of changes. There's a lot of effects that can change the purity of this water. One of those is more natural, but storm surges. So they will produce a rush of water, which does have some problems on its own. But the problem I'm going to focus on mainly is wastewater treatment plant overflow. And just for a little side note, if you see WWTP throughout this presentation, it means wastewater treatment plant, which we all know and love. We appreciate these treatment plants very much. But they do, nothing's perfect. So industrialization can also be a problem to our fresh water, such as toxic chemicals, microplastics, and metals. All of these industrialization pollutants can be put right into the water through unsafe water cleaning mechanisms and stuff like that. But something that hits a little bit closer to home is actually household chemicals. So a lot of us fertilize our gardens, we fertilize our yards to get really nice green grass. But the nitrogen and some of the other phosphorus, some of the other chemicals in that fertilizer can actually get into the water supply. And it can cause things such as eutrophication and some other stuff, which I'll kind of go into further as well in the end. But also organic compounds from a lot of our cleaners. And TCE, or trichloroethylene, is one of these big ones that used to be in Pine Sol and a lot of our detergents. it just ended up being very harmful to human health. So it's now EPA regulated. But I think what I want y'all to take out of this presentation especially is that we contribute more to this than we think we do. And there's certain things we can do with how we distribute or how we get rid of our waste that will make a difference long run. Some of the main freshwater health identifiers that scientists will look at to determine a water's quality is the pH, which natural water tends to be around 5.5 to 7. And this is just because of carbon dioxide in the carbon dioxide in the atmosphere and some of the other chemicals that will kind of work their way in through some chemical reactions. Alkalinity, which a lot of people, its definition or it's think about more as is resistance to acidify or is resistance to change pH, but it can be overly alkaline or under alkaline. That's also probably the more common way, but we think of it a lot as like alkaline water. One that I'm going to mention probably the most during this discussion is major ion composition. And I'll kind of go through a little bit of a list of what these major ions are. And most of them are natural to us. Like if you look at the periodic table, like sodium, potassium, a lot of those ions are contributing to some of the freshwater health. And those ions are typically measured using conductivity. So a high conductivity will immediately mean a high ion concentration. Turbidity also contributes to this major ion composition. And temperature and dissolved oxygen are not particularly involved with that, but they are also very important freshwater health identifiers. One last thing that's become more of a problem in recent years and is also kind of why I'm talking about these wastewater treatment plants are the total area of fecal coliform and fecal streptococcus, which are bacteria that get into the water that can cause a lot of human health damage, but also a really good identifier and tracker for where the water is being polluted. So, as I was saying before, this is where I'm from. To anybody watching, I'm from the Blue Ridge Mountains, and one of the bigger things that contributes to our freshwater health is debris deposition. So this kind of turns into the turbidity and major ion composition problems that I was talking about just before. But heavy rainfall disturbs the loose sediment and unstable sediments, or the loose and unstable sediments causing stuff like landslides, which are just a tragic incident if you've ever been around one. It can take out roads, homes, it can do a lot of damage. But to our fresh water, it also deposits a lot of debris directly into the water supplies. So this increases the turbidity and ion concentrations. And here on the right, I just kind of have a very basic diagram on what this could look like, or like why the debris will flow in a certain way if you're not from the mountains. So as you can see, it's just a very steep incline, but the surface sediment is very loose, it's unstable, it's new. So any amount of rainfall can cause all of that to run down, and rivers typically run in between these mountains, so in the valleys. So anything flowing from the top of the mountain is going to wind up more than likely into a river, a creek, a stream, anything of that nature. And a lot of that contributes to the fresh water that we drink if you're in like a more rural area especially. Here I have a bit of a diagram on the amount of rainfall it takes to cause a debris movement. So right down here, like very close to the bottom, even below like section A, which is just storms approaching this section A, storms approaching the threshold is very low. It does not take a lot of rain to cause a debris flow. So as we get into section B, like it's very most likely that the debris flow is going to start unless you have like a very old untouched mountain range, or land area within the mountain range, I should say. Section C is more of like very rare storms. If you guys are in environmental studies at all, you'll have heard of a 100-year storm, which is more of it's a percentage, as if it's like how they determine certain like safeties of areas. But it's the percentage chance, the amount of rainfall the highest probable rainfall amount that could possibly fall in 100 years. Merit may never happen in 100 years, but also could have a rainfall that overreached this within 100 years. So it's just like a probability thing, but the graph just kind of shows how low the threshold is and how likely it is that debris deposition will happen. So anthropogenically disturbed land areas are also more susceptible to debris flow. So this just means like any land building areas, any industrialization, anything where the land has been disturbed from its original or natural state. And in a way, it's kind of like we need industrialization, so who cares, or like why would we care? And maybe we don't particularly for our health, since we do have water treatment facilities, but many of the local animal life, they rely on the vegetation around them, but the vegetation also relies on them. So as large animals disappear, a lot of these plants rely on the wind and small animals for seed distribution. And since these large animals are beginning to die off, or not die off, but kind of move towards the less disturbed areas, it's led for the wind to kind of distribute these seeds, which it's not possible for all of our larger seeds, only for the smaller ones. So this has led to the extinction of many of local shrubs, and possibly some more in the coming years. So I'm going to transition now into the Piedmont region. So the Piedmont in general of North Carolina is a very much so flatter terrain. There's more industrialization and less natural land areas, except for like the small forests in between industrialized properties kind of deal. So this as well doesn't allow for much wildlife. But the main problem in this region is actually the chemical and heavy metal pollution. So with this industrialization, a lot of the waste holds stuff like iron, calcium, magnesium, aluminum, sodium, and silicon. And this mainly is from combustion waste, which if you're from North Carolina, you know about Duke Power Plant. Which, I mean, obviously we all appreciate Duke as very much. It supplies our power, but at the same time, like, we're still learning how we need to control this waste to make sure that we're protecting the environment as well as seeking the benefits that it gives us as well. And something new it's pretty new at least, and if you're in high school, you may not have like talked about this very much yet. But another chemical manufacturing plant that resides in North Carolina is a PFAS manufacturing plant. So PFAS are kind of coined a forever chemical. So it's a chemical that is incredibly resistant to water. So anything you wear, like a waterproof jacket or anything that is water resistant, is made containing PFAS, and that's what gives it its water resistant qualities. But when these PFAS chemicals get into the environment, they have been linked to possibly being a human carcinogen as well as just harming the animal life. But once they're in our bodies, they will accumulate. We don't necessarily get rid of them. So although this is a new and emerging issue, this is something that is becoming wildly important and something I do kind of want to touch on. So for chemical waste and for electricity generation specifically, combustion reactions. So it's basically where you take a natural resource such as coal or natural gas, any of that, and you burn it. And in burning it, you are going to capture a lot of that energy. Not necessarily all of it. Like, it's not 100% sustainable and all of that, but you do capture a lot of that